This is a recording for Edexcel Further Pure 1, Coordinate Systems 1, the Parabola and Rectangular Hyperbola. Section 1.4, which looks at the focus directrix properties of the parabola. This diagram shows a parabola with standard equation y squared equals 4ax. The parabola can be considered as a locus, in other words a point moving, and that point is represented on the diagram here as P. So this is a general point on the parabola. And the locus is such that the distance from a fixed point, which is called the focus, is equidistant from a point on a line which is called the directrix. So these are new terms that you need to know. The focus is a point, the directrix a line, and the distance of the point moving on the parabola, P, is equidistant from both the focus and the line. Or in other words, this distance here from S to P is exactly the same as the distance from P to X. So we can say that SP is equal to Px for all points on the parabola. Notice that distance to Px is at right angles, obviously, to the line. So it's the shortest distance from P to the directrix. So the focus is on the x-axis here. S has got coordinates A, 0. Now, how do we know that it's A0? Well, the parabola goes through the origin. This is actually referred to as the vertex of the parabola. And therefore, the distance to S and the distance to the directrix being the same means that those are both equal to A. Therefore, this distance here being equal to A means that the focus must be at the point A0. The directrix is a line, and it goes through x is equal to negative a, and therefore the directrix is the line x is equal to negative a. So this diagram just puts the same things on a nice neat one, so you can pause it if you wish and make some notes, or come back to it at a later date. So there we are. The general point is moving along the parabola such that the distance from the focus is equal to the distance from the directrix. It is handy if you can remember these facts. However, don't worry, because they are given to you on your formula sheet. So if you're unsure, always check that you have got the correct expressions by looking in the formula sheet that you're given in your exams. Well, here's a fairly typical example which uses those facts. Here we have to find the Cartesian and parametric equations of a parabola which has focus at 9, 0 and directrix equation x equals negative 9. Well, either of those can be used to show us that a must be equal to 9. For example, the focus S is at A, 0, and so that means that A is equal to 9. Once we've got that, we can quote the fact that the Cartesian equation is y squared equal to 4ax, and that means therefore that we have y squared is 4 times 9, 36x. The parametric equations are given by x is equal to at squared, y is equal to 2at. So therefore we have x is equal to 9t squared and y is equal to 18t. So straightforward use of those properties. And remember again that you literally don't need to remember that the focus is at S is A0 and that these are the parametric equations, because these are given to you on your formula sheet. This second question uses those ideas the other way around. So here we're given, first of all, a parabola where in its standard form y squared is 4ax, and in the second part of the question a different parabola where we've got the parameters for x and y. So let's look at part A first of all. Y squared equals 4ax means that we have that 4a must be equal to 2 root 3, and therefore a is equal to root 3 over 2. So the focus is at a0, so that's root 3 over 2, 0, and the directrix is at x is equal to negative a, which is negative root 3 over 2. In the second part of the question, this time we're given the parameters for x and y, so either of these can be used. Let's look at x. We know that x is equal to at squared, and this means this time that a is equal to 8. And so the focus is at 8, 0, and the directrix is at x is equal to negative 8. And there we are with those two things written out nice and straightforwardly, so you can refer to it later. Well, that's the end of this particular recording. In the next one we'll be looking at some problems involving the parabola.